Okay, so today we are going to be doing a review of multiplying and dividing decimals. Dividing would be a good word. There we go. Now, I'm going to break this down in my screen. Left side multiplying, right side dividing. We're going to just go over some things we do or don't do for each one of those operations and then do a practice problem. So on the left, let's go ahead and deal with multiplying. And then on the right, we'll deal with dividing. Okay, so I'm going to start with something that we don't do when we're multiplying with decimals. We don't line up decimal points. Okay, that's something we do when we add or subtract, but it's not what we do when we multiply. So we don't line up decimal points. They don't need to be the same length. They don't need to have the same number of digits. That's not necessary when we're multiplying with decimals. Something we will do count the number of digits each original number has after the decimal point, or after decimal points. Each original has after its decimal point. Let's do it that way. So I'm going to demonstrate and I'll show you off to the side. I'm going to do some counting, and the answer that I get altogether is going to help me with my answer. Do multiply vertically. Nobody likes to multiply horizontally, as if the decimals don't exist. Okay. And then do place the decimal in the product. That's the answer to a multiplication problem. The number of digits you counted earlier from the right. So I know that sounds really yucky. Okay, so let's go do the practice problem, and it's going to be crystal clear. All right, where is my, here's my beautiful problem. So our example, directions are going to say multiply, they may just say simplify. And we're given a problem, generally speaking, just a number times a number. So we're going to have 3.25 times 1.7. Okay, so what I'm going to do is take these numbers, and I am going to write them vertically. But what I'm not going to do is I'm not going to count up, or I'm not going to line up those decimal points. Okay, now says do count the number of digits that come after each decimal. So I have 2 on this one, I have 1 here, for a total of 3. So I'm going to save that number, and that number 3 is going to come into play once I do the multiplication. So now do multiply vertically as if there weren't any decimal points. So 7 times 5 is 35. 7 times 2 is 14. 14 and 3 is 17. 7 times 3 is 20, plus 1 is 22. Put in a placeholder, and then I have 1 times 5 is 5. I love multiplying by ones. 1 times 2 is 2, and 1 times 3 is 3. And then I add those guys up, and I get a 5, I get a 12, I get a 5, I get a 5. And then I'm going to go back, and I'm going to use that 3. So how it works is I go to the end of the number, and I start at the right, and then I go 1, 2, 3 places to the left. So that's what I mean by counting from the right. I counted 3 from the right. So my final answer works out to be 5.525, or 5 and 525 thousandths. Okay, let's talk about dividing. We don't divide by a decimal. So that means if your divisor, the guy outside the division house, has a decimal in it, you're going to have to multiply by some power of 10 to make it a whole number, okay? And then do treat each number the same. Meaning, if I move the decimal 2 places in the divisor, I got to move it 2 places in the dividend, okay? Now, setup. Let's talk about that guy. So we have a dividend. Oh, dividend. I don't think so. Dividend. And we're going to divide that by a divisor. And that's going to equal that funny word in math, quotient. So when I divide by the divisor, it will be the end of the number that we began with. Now, how does this translate to when we do long division? Well, we're going to start with our dividend. And he's going to go under the division house. There's that division symbol is now that kind of sideways capital L. The guy in charge is the divisor. He's the supervisor of division. And I should have given myself some room. The answer is the quotient. Okay, so we got to, that's probably the biggest problem I see is people not setting the problem up correctly. So I'm going to write underneath here, do set up the problem correctly. Okay, so let's go ahead and we're going to launch into our practice problem. Man, I did this like 3 times before I finally came up with a problem I wanted to do, and I think this is my final version. So our directions are going to say divide. It may just say simplify. That's catch-all for do all the math you can do until there's nothing left to be done. So we're going to be giving it to you this way, horizontally. 3.7815, or let's see if I can read this properly. 3 and 7,815 10,000ths divided by 0.15 or 15 hundredths. So first thing we do is we set up the problem correctly. So the first number is the dividend. He's the guy that goes under the division house. The divisor is the number that came after the division symbol because he's in charge of the division. Now, we can't divide by a decimal, so this is what this looks like. I'm going to have to multiply. If I multiply by 10, it's just going to move the decimal point once to the right. So I have to multiply it by 100. So that means I multiplied by 100 means I move the decimal point twice to the right. So I do the same exact thing to my new guy. Now, the decimal point no longer exists between the 3 and the 7. It exists between the 8 and the 1. So I'm going to bring it straight up. So I'm going to rewrite that problem cleanly. And now what the problem is 15 dividing into 300. Hello, I got distracted. 378.15 hundredths. So decimal point straight up, and then I start dividing. 15 can't go into 3, but it can go into 37 twice. So I put that 2 over the last digit of the number that I'm dividing into. If this is as far as I can divide, then my quotient guess has to go directly above the last digit, the ones digit. So 15 goes into 37. In fact, let's keep it purple. And that's going to be a 30, and then we subtract, and we get a difference of 7. As long as that difference is smaller than my divisor, then I've guessed correctly. Then I get to continue the problem by bringing down the next digit. Now, how many times does 15 go into 75? I've done this so many times, I've memorized it. It goes in 5 times. 5 times 5 is 25. 5 times 1 is 5, plus 2 is 7. And then I get a difference of 3. And then I don't worry about the decimal point anymore, right? Because he's already placed into my answer. So I bring down the next digit, 1. And then 15 can go into 31 twice, which is 30. And I get a difference of 1. And then I bring down the next digit, the 5. And 15 goes into itself exactly 1 time. Duh, English. 1 time. And we get a terminating decimal. So I'm going to write that. We can either have a terminating decimal, and that means no remainder. No, what was I going to write there? Remainder. Or we could have a repeating decimal when we have the same number shows up multiple times. So we kind of decimal. Oh my goodness. I'm just going crazy with my spelling. My brain's someplace else. So let me show you an example of what would happen with the repeating decimal. So let's say that you were dividing and you got 3.76666, and it just kept going on. So what we do is we stop, we write all the digits, unique digits, once, and then we put a repeating bar over just the piece that repeats. So it just goes over the 6. Okay? So there we go. That's what we're doing. We got an answer here of 25 and 21 hundredths. And there you go. Good luck with this, guys. Bye-bye now.